Hello students, welcome to Gangs of Toppers. In this session, we are actually covering the topic that is condensation. We are going through the topic that is condensation. This is very important topic, okay? Now, condensation is the reverse process of evaporation. Yeah. As we have already studied that what is evaporation, it is the process by which water is converted into water vapor. Okay, then that is called evaporation, and it is the actually just the reverse process of evaporation. Means here the water vapor is converted into water molecules. That is called condensation. Now in condensation, water vapor in the atmosphere get converted into water droplets. As we have already studied that this is actually the process or reverse process of evaporation, or we can say that in condensation water vapor in the atmosphere is getting converted into water vapor or ice droplet. Means here that is water vapor that is present in the atmosphere is converted to water droplets or ice. Now during condensation, the latent heat locked in the water is released back into the atmosphere. Now it is very important, as you have already studied in the last session, that what is the latent heat. Okay, latent heat is the energy absorbed or energy released during the change of the state of phase. Means actually here it is talking that if you are converting the water into water vapor, then there is a change in state of phase. Means what? Here water is converted into water vapor, means for sometimes energy is needed to convert hot amount of water into water vapor, and that energy that is absorbed, and that is called the latent heat. Now if you are again the reverse process of evaporation condensation, means here that water vapor is converted into water, means water vapor is going to convert into vapor. Sorry, what is water vapor actually converted into water? So in this process actually, in this process the energy is released. In this process the energy is released, that energy is called the latent heat. Okay, and it is actually released into the atmosphere. Condensation can take place only when water vapor is added to saturated air, or when the temperature falls below the temperature at which the air becomes saturated. Now here are the two conditions it is saying about that how the condensation takes place. Now the, as we have already studied that when the relative, when the RH become, what is this, when the RH become, when RH become 100%, then the temperature at which the RH is equal to 100%, then that point is called the dew point. Okay, and from this dew point condensation start. From this dew point condensation start. Now I'll tell what is this. As you have already studied what is RH, that is the relative humidity. Relative humidity means that RH is equal to, that is the amount of water vapor, divided by maximum amount of water vapor that it can hold. Okay, now we're talking that it is saying that the condition that the condensation can take place only when water vapor is added to the saturated air. Now it is saying that when we are going to add more water vapor. Now we are talking about this condition that when we are going to add the amount of water vapor that is in the air more. Okay, means it means that when we add water vapor in the air, then in this condition the RH value is going to increase. Now if this RH value is going to increase and it increases up to 100%, then what is this the point at which the RH is equal to 100%, or the temperature at which the air gets saturated, then that is called the dew point. And from here the condensation start. Now from which we understand that first how we are going to take the condensation, first by adding water vapor into the air. Now second point is that when the temperature falls below the temperature at which the air becomes saturated. Very interesting this concept. Look here, it is saying that, you can see here, suppose this was the volume of air. Okay, suppose we are talking about this volume of air and it contains at example is that it at 25 degrees Celsius or temperature, air can hold 30 gram and 30 gram of water vapor per cube centimeter. Now suppose at 25 degrees Celsius, this volume of air occupy how much gram? That is 25 gram of water vapor. Now suppose, but it is saying that at 25 at 25 centimeter at 25 degrees Celsius temperature, air can hold 30 gram of water. Means it is talking about that it is a 30 gram of water. Okay. Now, if we the temperature there is going to fall 0, means now we are going to fall the temperature to 0, means at 25 degrees Celsius the volume where that is the intermolecular space between the molecules is more, so the volume where we are talking about this is big, consider is big. So in this case it acquires that is how much, 30 gram water. Now we are going to decrease the temperature to how much, that is 20 degrees Celsius. Now if you are going to decrease the temperature, it means what, means we are actually decreasing the intermolecular space, means the density of air is going to increase, means the intermolecular space between the molecules, intermolecular space between the molecules of air is going to decrease, means the volume of air this is going to decrease. If the volume of air is going to decrease, means that this volume of air does not occupy more water vapor, means it will hold only how much gram, that is 24 gram. Now once again you see that is if at 25 degrees Celsius, the temperature, the air can hold how much gram? That is 30 gram of water vapor per cubic centimeter. But if the temperature falls to 20 degrees Celsius, now we are going to decrease the temperature. So in this condition, it can hold only 24 gram of water. Why? Because the air become dense. The air become denser, so it is not going to hold more water. Now what is going to happen? So this earlier it was holding 30 gram, and now it is holding only 24 gram. So what is going to happen for 6 gram? This 6 gram is going to condense. Is this the remaining 6 gram of water vapor will be get condenses. Okay. So we from this we have concluded that first in order to make the condensation process and start, first of all we have to add water vapor into the atmosphere, and second we have to decrease the temperature. So we have to decrease the temperature. I hope it's okay. Now, condensation can take place when the following atmospheric condition existed. Now, it is talking that condensation can take place when the following atmospheric condition is going to exist. First, there should be high amount of water vapor present in the atmosphere. Already studied. Now, if in order to increase or in order to make the air humidity, means we have to add a high amount of water vapor that is present in the atmosphere. Second one is that in order to form, very interesting one. This is very interesting data. What is it going to say that? Minuscule particles means what is hydroscopic. It is talking about the hydroscopic nuclei. It is talking about the hydroscopic nuclei. Please remember this one. This is hydroscopic nuclei. Hydroscopic nuclei, that is the minuscule particles. What is talking about? Minuscule particles of dust and the salt, even smokes, act as a condensation nuclei. Means this is condensation nuclei and also called as hygroscopic nuclei. That is the particles around which water vapor is going to condense. Now actually we are talking about that if we are having condensation, the process start there in the atmosphere they need a hydroscopic nuclei. Means we are talking about that if there is no hydroscopic nuclei, then water vapor is not going to condense. Means it needs a medium, it needs what, it needs a situation, that it needs what we said, that this is in this hydroscopic nuclei, so that water vapor is going to condense on this nuclei. Okay, you can say this is necessary condition to having the condensation to start. Second one is that the temperature of the air must be below the dew point temperature so that it increases. Now, third point we have already studied that in order to make the condensation start, we have to decrease the temperature. So that the condensation can start. So, okay. So it is talking that the air temperature must be below the dew point so that it increases the condensation. I hope it's okay. So first of all we have to remember that in order to make the condensation start, first point is that we have to have huge amount of water vapor. Means we can say that we have to increase the amount of water vapor present in the atmosphere. Second is that presence of the hydroscopic nuclei, and the third point is that we have to decrease the temperature below the dew point so that it increases the condensation. Now this is a very good example, that is okay. Now we will talk about next topic is that is the forms of condensation. Okay, first one is that clouds. You can say this is a cloud. Cloud when the invisible water vapor. Now we have already know that water vapor that is present in the atmosphere is invisible. So we are talking about that clouds forms when the invisible water vapor in the air that is going to condense into visible water droplets or ice. Now first point we have to remember that the invisible water vapor that is present in the atmosphere is going to condense into visible water vapor or ice crystals. There is water around us. Now we know that there is water around us all time in the form of tiny gas particles that is known as water vapor. Already studied because we know that there is water vapor that is present in the atmosphere and that is in the form of tiny gas particles. That is in the form of water. That is in the form of tiny gas particles and it is known as a water vapor. Now, it's very we are talking about that tiny particles floating. We are talking about that is that tiny particles floating that is called the hygroscopic nuclei. That is called the hygroscopic nuclei. Hygroscopic. So we are talking about that. There is a tiny particles that is floating around there, such as salt, dust, and smoke particles and all. And these are called aerosols, and you can say that these are the hygroscopic nuclei. Now, water vapor and the aerosols. Now we are talking that this water vapor and the aerosols means what hydroscopic nuclei are constantly bumping each other. Means they are accurately bumping. They are attacking each other. And when the air is cooled, some of the water vapor sticks on the aerosols. Means when this happens, some of the water vapor is going to stick with this hydroscopic nuclei, and when they collide, and this is called the condensation. This is called the condensation. Eventually, the bigger water molecules form around the aerosols particles. Means eventually these small water molecules is going to form a bigger water molecules that is around the aerosol particles, and these water start sticking together with other droplets and forming a cloud. I think so. This is the formation. This is the step. We can say that the formation of cloud takes place. Now we have clouds. We have different types of clouds. So we'll study that is a cloud. Clouds when form, that is the clouds when the air is saturated. Now we're talking about that when the air is saturated, when the RH become 100%. The RH become 100% means it means that it cannot hold any more water vapor, and this can happen in two ways. Means so we can say that the cloud forms when the air is saturated. We are talking about that cloud forms when the air becomes saturated, or it means that it cannot hold any more water present in the atmosphere. Okay. Now, the amount of water vapor in the air has increased. Now, we are talking about that. The first condition is that in order to happen the cloud formation, we need to know that the amount of water vapor that is present in the air is going to be increased. Then, in this condition, that is the point that the air cannot hold any more water. Now, if you are going to increase the water vapor in the air, then what is going to happen? It means that a point will come that it is not going to hold any more water. So if it's not going to hold any more water, then the cloud formation start. Means it will go to a point at which the air cannot hold any more water. So if this point happens, then it means that the dew point is going to achieve. Now if the dew point is going to achieve, it means that the cloud formation start. Second point is that the air is cooled to its dew point. Now already studied that if we are going to decrease the temperature, it means that it happens at which the temperature, or if you can say that if you are going to decrease the temperature to its dew point, the point where the condensation occurs and the air is unstable to hold any more water. Means in this condition air is not going to hold any more water. Now, as you already know that the warmer air is warmer air. If air is warmer, means we are talking about that. If air is warmer, it means that the more water vapor it can hold. Okay, we are talking about that. Very important concept. Please remember that we are talking about that. If the air is warmer, means what is going to happen? This intermolecular space between the molecules of air is more. So if intermolecular space between the air molecules is more, it means that it has more capacity. It has more capacity to hold water. Very nice, because in this condition, because the air is sparsely distributed, we can say that okay, and the intermolecular space between the air molecules is more, so water vapor can hold more. Now, clouds are usually produced through condensation. Now, already studied that clouds are usually formed due to process of condensation. In this, what is going to happen? The air rises. The air, you can say that is the air rises and it cools and reducing the temperature of the air and decreasing its ability to hold water vapor, and so the condensation starts. And you have to also remember that what is condensation level means the height we're talking about the height at which the dew point is achieved and the cloud is formed is called the condensation. It's called the condensation level. Now we will study that is the types of cloud. We have there are four basic cloud that is categories that is observed in our atmosphere. So you have to remember that there are four basic cloud categories that are basically observed in the atmosphere. First one is that is a zero. First one is zero. Okay, we have to remember that what first one is a zero, and the second one is what? Second one is about nimbo form. What is it? Second one is about, you can say that is nimbo, and the third one is about that is a first one you remember this one, that is a zero. Second one is you should remember that is what is a cumulo form, cumulo, and the third one you have to remember that is a nimbo form, and the fourth one you have to remember that is strato form. Okay, so if it is saying that what is zero, so zero actually means what is, you can say that is a zero means that is high up. You can say this is high up and wispy. It is high up and wispy. You can say in the example that is a zero. This is cirrus, we can say, and this is a high ups. This is a high up, and we can say, and wispy. You can say that is what is the height. This is above that is 7,000 meter. Means the height, it is the top of the height. You can say that is it is a high cloud. It is a cloud high. You can say that it comes under the cloud high. Or what is the indication of this? It is highly up and wispy. Highly up and wispy. You can say there. Okay. Best example you can say that is a cirrus, and this is highly up. Okay, you will say like this. So the example is here. It is written that this is cirrus means what? Highly up. Second point is that what is a cumulo form? Cumulo form, that is it is looking like a cauliflower. It is looking like a cauliflower. So you can say that is it is looking a cauliflower. So cauliflower, actually this is a cauliflower. Okay. Cumulo. Okay. Just remember cumulo, that is indicated by that is what? Cu. This is actually what? This is actually a cumulo. This is actually a cumulo. You can say the example. You can say this is a cumulo. It is actually looking like a what? It is actually looking like a cauliflower. So remember this one, that is cauliflower. And the third one is about that is what is this? That is about the strato layer. This is about the strato layer. So you can see here that is this is strato. Okay, this is strato layer. Okay, means it will have a gray, that is it has generally have a gray cloud layer with a uniform base. You can say, so it's come under, that is what it comes under. You can say that is what is a strato, that is a flat and layered, layered and smooth, flat, layered and smooth. So, and the last one is about that is alto. It comes under the, that is a medium cloud. There is a alto. And the last one is about, this one is very important, that is nimbo form. Nimbo form, that is a also known as rain bearing cloud. Okay, so types of cloud, because there are basically three levels, that is cloud level and medium level and the high level. You can say in the diagram that is this one is comes under the low cloud, this all the comes under low clouds, and after that middle cloud, and after that we have high cloud. Okay, so this is actually divided into three part, and these there is a combination. Means what is going to say that the names of the clouds are usually are combination of the following prefix and the suffix. Now it is very important that here that is the names, that is present, the names of the cloud are usually are the combination of the prefix and the suffix. Means what it is telling that if it is a strato, means what we say in short form we used to write a strato. Okay, what we used to write for a short form strato, that is st, and for the cumulo, that is cu, and for the cirri, that is ci, and for alto, alt, and for nimbus, that is ni. Okay, so what is going to happen, that is if you write this strato and cumulus, means what, cu and strato, what is going to happen, that is we are talking about that this cloud, that is this cloud is a cauliflower structure with a base of what, base of a stratus. Okay, so we will see this in this diagram, that is this is a stratocumulus, means the base is the what layered, and it has a cauliflower like a structure. Okay, and if we only talking about this is a cumulus, means it's only a cauliflower. Okay, so I think you should go through this diagram. It's okay. Now we will study what is now second point is that this point is over. Now we will talk about, we will go through the book. When a cloud is fully saturated, now we are talking about that when the cloud is fully saturated, or it means that it is or it means that relative humidity is 100%, then the precipitation starts. Warm moisture. Now we talk about the warm moisture that is near the ground, that is rises into the sky. Now we are talking about that how it is going to happen. That is it is saying that is the warm air, that is the warm moisture that is near the ground is going to rise into the sky, and since the temperature is going to decrease with height, that is the ascent cause reduction in the temperature. Means the ascent cause, that is the going and the acting or the act of going up of the air, or we can say that is the going up of air, that is causes reduction in temperature, because in height the temperature is going to decrease, and that is if the temperature decreases to the below point and the moving air on colliding with dust particles. Now we have already talked that this moving air or this water vapor will collide with the hygroscopic nuclei. Okay, sets the extra moisture, means after that they are going to set the extra moisture, and this lead to the condensation in the form of tiny droplets of water. And it is important to remember that the condensation occurs only around tiny solid particles like dust, carbon dioxide in the smoke. We have already studied this one, because this is the hydroscope. We can say that in the condensation is only happen if it occurs on only around the hygroscopic nuclei. Condensation can only happen around the hygroscopic nuclei, already studied. Now these impurities in the air, now we are talking about the hygroscopic nuclei, that is these impurities in the air is known as condensation nuclei. These impurities that is present there is known as condensation nuclei, or also known as hygroscopic nuclei. Without condensation nuclei, that is condensation does not take place, already studied, because it needs a medium. Without condensation, that is cloud do not form, and without cloud, that is precipitation cannot occur. We are talking about that if this hygroscopic nuclear condensation nuclei is not present in the atmosphere, then a cloud is not going to form. Okay, and it means that if cloud is not going to form, that without cloud precipitation cannot occur. Now, product of condensation means we are talking about that is the water vapor. Water droplets are so tiny that they remain suspended in the air and do not fall in the ground. Means we are talking about that that is the product of condensation are so tiny that they remain suspended in the air and do not fall to the ground. Then the cloud rise, means these water droplets is going to combine more and more, it becomes more, and the cloud rises as more and more droplets are added. The cloud slowly grow in the size, and then as more and more, that is droplets is going to rise, the cloud slowly grows in the size, and when it cannot hold any more moisture, or when the air is fully saturated, means it is talking that when it cannot hold any more moisture, or when it cannot hold any more moisture, means what we are saying that if when the air is fully saturated, means what happened, we are actually increasing the moisture, or we are actually increasing the water vapor in the atmosphere, means it means that it is not going to hold any more moisture, or we can say that air becomes saturated, or it is the relative humidity becomes 100%, and the moisture becomes down and it becomes rain. Okay, now already studied that is classification of cloud. When the cloud rises, they takes place, they take different shape, because depending on the shape we are going to divide the class, we are going to divide, or we are going to classify the cloud. Okay, but not all the cloud cause precipitation. It is very important that you have to remember that not all the cloud cause precipitation, only there are different where there are few cloud that cause precipitation. Cloud may be grouped according to their formations in the atmospheres and their shape. Now we are actually dividing the clouds. So clouds are divided according to the differences, and these are grouped according to the formation in the atmosphere and their shape. Okay, now we have already gone through this, that is a cirrus means what? Cirrus means that is a fleecy like wool, and generally high altitude. It is at high altitude, and it is actually like this. Okay, now we have cumulus, that is cumulus means cauliflower like a structure, and a stratus means that is layered structure, means a stratus. Okay, now the base of the cumulus cloud, now we are talking about that this base of the cumulus cloud is horizontal, but they have vertical structure, because we are talking about this cauliflower, means the base is actually horizontal, and they have a vertical structure, and the top is doomed, and their top is doomed, means what? You can say like this, and they are generally termed as rain bearing cloud, means we are talking about cumulus, they are generally a rain bearing cloud. Okay, now we will study about what is fog. What is fog? Okay, after that first go through the topic, that is dew. When the water vapor condenses, when the water vapor condenses on the surface, it forms tiny droplets of water. Now we're talking about when the water vapor that is condenses on the surface, it actually going to form a tiny droplets of water. Means we are talking about that when the water vapor that is going to condense on the surface, it forms a tiny droplets of water, that is called the dew. Okay, and this dew is generally occur during the winter, on accounts of cooling of air that is below the dew point. Once so it means it is talking about that in winter season, that is the water vapor that is present in the atmosphere is now when the temperature become low and it reaches just below the dew point, you can say that, or you can say the temperature at which the air becomes saturated, then this water vapor is going to form a tiny droplets of water, and that is called the dew, and that is called the dew. Okay, now after that we'll study about what is frost. What is frost? In very low temperature, now we'll talk that in a very low temperature, when the condensation occurs at 0 meter or ground level. Now we're talking about that in a very low temperature, means the temperature is very low. The temperature is very low, or you can say that the temperature is below the dew point or below the freezing point. When the condensation occurs at 0 or below the ground level, the water vapor freezes into minute crystal of ice. Water vapor is going to form into minute crystal of ice or the on objects near the ground. On objects near the ground, or you can say that as the blades of grass, leaves, and the tiny rocks particles. And frost is harmful to the plant. It is very important that this frost is going to be harmful to the plant. Now, it is talking about that as it is actually a dew point. Okay, or you can a dew point. If this dew point is just below the freezing point, just below the freezing point, okay, then what is going to happen? This water, that is droplets, is going to freeze, and it is actually deposited on the object that is near the ground. It is actually going to deposit on the object near the ground, such as the grass and the tiny particles in the leaves. And this frost is very harmful to the plant. This frost is very harmful to the plant. Once again, please go through this topic, that it is very in a very low temperature. Okay, we're talking about that in a very low temperature, when this condensation occurs at a 0 meter. At 0 means it is actually forming on the ground. It is actually forming on the ground. Okay, water vapor freezes into minute crystal of ice. Mean these water droplets is going to freeze into minute droplets of ice, and it is actually deposited on the plants, grass, and the rock particles. And frost is very harmful to the plant. And the last one is about the fog and the mist. Okay, now fog and the mist are two related terms. Now it is very important that this fog and the mist are two related terms, and the droplets of water that is suspended in the atmosphere that is close to the surface of the earth are termed as. Now it is very first remember that what is fog. Fog is actually or water, that is the droplets of water. It is actually a droplets of water that is suspended in the atmosphere. In the atmosphere. We are talking about that droplets of water that is suspended in the atmosphere that is close to the surface of earth. Means what? It is near to the surface of the earth, and that is termed as the fog. Now we will talk that in a long winter nights. Means suppose if in a long winter, like suppose in December, the ground cools more rapidly than the air above it. It's very important that because what? Because land is actually a good absorber of heat, as also at the same time it releases the heat rapidly. So we can say that the ground cools more rapidly than the air above, and such cooling reduces the temperature at the surface below the dew point. And such cooling, what is going to happen? That is the surface of the earth is going to become the below the dew point, and the water vapor at the lower surface get condensed, and the water vapor that is at the lower surface is going to condense around the minute solid particles, and it is called fog. What is called mist? Mist is actually less dense than the fog. Now it's very important that mist is actually less dense. Means the density of mist is less dense in the fog, and the visibility is better. Now we will talk about, in case of fog the visibility is not good, but in case of mist visibility better. Visibility during the fog that is extends less than 1 kilometer, but under condition of mist it may go up to 2 kilometers. Now it's talking that mist is less dense than fog, and the visibility is little better. Means talking that visibility during the fog extends less than 1 kilometer. In 1 kilometer we are not going to see anything, but if we talk about the mist in 2 kilometer, we can up to 2 kilometer we cannot see anything. After 2 kilometer we are not going to see anything. Okay, now if there is any more point left, okay, we talk about the what is that is fog. We have already said this is a fog. This is the condition of fog. Okay, and generally happens in the winter season. And about, if you talk about the mist, you can say that is this is about the white frost. This is we are talking about the frost. Okay, means frost means what? The cool surface when the condition takes place below the freezing point, and the point at which the dew point at or below the freezing point. Okay, and this condition the water molecules is going to form ice crystals. Okay, थैंक यू दोस्तों।